Hi, class. Good morning. We're going to be talking today about the internet and making use of its resources. So let me go ahead and share my screen and we can get going. Yeah, we're going to describe how the internet got its start. It was for communication between our military branches, our being the United States. We'll see how data travels on the internet. It's through what's called a wide area network. And it's just a bunch of networks talking to each other through devices called routers and firewalls. We'll look at tools for collaboration and communication, things like Zoom, Teams, SharePoint, Google Hangouts, Google Drive, things like that. We'll look at personal communications over the web. We'll look at what cloud technologies are. And as a little head start, IT professionals consider the cloud to be the internet. When we look in the sky, we don't know how a cloud was formed. And frankly, we know how the internet got its start, but we don't know the depth of where it reaches. We'll look at how business is conducted through the internet. We call it e-business, meaning electronic business, or e-commerce. And we'll look at some models being consumer to consumer, things like Poshmark, Mercari, Vivid Seats, StubHub, eBay. We'll look at business to consumer, Amazon, Walmart, Nike, all your big brands. And we'll look at business to business, where business conducts sales with other businesses. We'll look at precautions to doing business online. We'll see what a web browser is. I think most of us know what a web browser is, but it is a software program, an application, let's say, that accepts inputs from your mouse, keyboard, camera, whatever, processes it, looks at what a URL is, and we'll see how it's made up, and then determines how these requests, these keyboard requests, are routed. And we do that through routers and firewalls, which we'll talk about shortly. And we'll look at other tools to navigate the web. We'll look at tools to search the web. We're going to really start and end at our library. Well, how to evaluate a website. We'll look at understanding ethical issues using the internet. And we're going to see how we're able to conduct ourselves in an ethical manner. There's generally accepted rules for ethical and proper behavior on the internet. I'm not in a position to share my ethics with you. I'm going to share to you again what's generally accepted. So what is the internet? First, we have to look at what a network is. So we're going to think of a network like this. I'm going to draw my famous stick figure. And I'm kind of grumpy. And we'll do another person. So this right here, communication between these two people could be considered a network. It's a person network. Now let's expand this times 100. Now we have a 200 person network. Now this network is much more powerful than when it was just us too. So when we're thinking of people networks, I want you all to get a LinkedIn account You can search for me, pretty easily found. But it's important to start collaborating and communicating and building a professional network. I'm sure we're all well versed in social networks. LinkedIn is just a business version of that. Let me get out of that. Let me go to here. So the internet was established to be a secure communication form between the U.S. Army, Navy, Air Force, Marines, and Merchant Marines during the Cold War. A gentleman named Bob Dole decided, hey, let's make the internet available for everyone. We started to see things called internet service providers pop up in the late 80s, early 90s. Things like AOL or CompuServe were both famous for that. Then we decided to make the internet a little more free and gave internet service provider standards to things like telephone companies and cable companies to where we are today, where we can get internet from pretty much any supplier we want, whether it's coaxial cables, whether it's fiber optic cables or satellite. We have a pretty easy way, if we can afford it, to get onto the internet. We're not going to talk about a rapid net. I'm not so much concerned about our history of the internet. It started with what's called an ASCII code, where we link a bunch of numbers to letters and build things called binary code. And this is called assembly language. We see the dates here. We're talking 60s, where we started to have some kind of shared data. In 64, we started to have communication via simple routers all over the US. So we use the terms World Wide Web or web to be synonymous really with the internet. They're actually not similar things. The internet's a lot more than the World Wide Web. www is a service on this bigger platform called the internet. It's built up with a bunch of things called websites who have web pages under them, usually coded in HTML or Python or another programming language. We've seen www really started in 91, and it's grown to where we are today. Client-server networking is the foundation of the internet. It's foundation of pretty much all computing today. So we start with a client. This is my computer, my keyboard, my mouse, and myself again. I got a little shorter because I'm sitting in a chair. So I've typed something into our keyboard, which is connected to our computer through a cable or through USB. Same thing with our mouse. And what this client does is actually send out a request. And I'm not going to try to write request there. I can put in a plain text. We have a request there. This request gets routed ultimately to say West MSMC.edu. We're going to the Mounds homepage. So we find our way there through a series of protocols where we finally then get to a web server. So this web server takes this request, okay, so we take that request. Sorry. What this web server does is it hosts a bunch of web sites. These websites are set up through wireframes. Now, wireframe is just a technical term for a grid where we can store content, but it doesn't house this content. So from there, we go to what's called an application server. What the app server does, this holds the programming languages that will take this request and route something back to this web server. So this is where all this web browser programming comes into play, or website programming comes into play, again, through things like HTML and Python. What the app server then does is this. We get another server connected to us. This one is called a database server. So this DB server takes a request from this app server, searches for it with index data. And I should tell you, data is raw facts that don't mean anything until processed. So we could have something sitting there and not have any meaning until a browser tells us we need something. So right now we need the msmc.edu backbone web page, website, I should say. So web server says, hey, y'all, I need the homepage for MSMC. App server says, okay, I got it. DB server, let's fill this page for a non-logged in user. Okay, here you go. Web server, here you go. Al at the Mount, here you go. This is still the foundation of computing today. The internet itself works off of a protocol called Internet Protocol. And this is a series of addresses that uniquely distinguish a computer to this thing, the network. Just going to stop my share for a second. So I'm running a Windows computer, and within it, I'm accessing a program called Command Prompt. This models the old Microsoft operating system called DOS, and these commands have been around forever. So I ran an ipconfig/all. So what this is telling me is I'm getting all the unique stuff that connects my computer to Zoom right now, where I'm hosting this lecture. So I have my computer's name. We have all the internet adapters I have installed. Immediate disconnecting means that's what's not running. So I finally get here to my wireless LAN adapter. What I wanted to show you are these. So this is an IPv4 IP address, 192.168.1.184. This was the standard for IP addresses being given out either physically with typing it directly into a setting or dynamically through a program called DHCP, Dynamic Host Control Protocol. And we see I have a similar address for that. I told you the internet works off a series of routers connected to each other, and that's what a default gateway is. And here's what that gateway is. So my IP address 192.168.1.184 is coming from Spectrum. I probably get 254 such IP addresses for my home. A big problem happened a few years ago, though. We'd run out of IP4 addresses based on so many devices in the Internet of Things taking up addresses that people never thought we need. So a new standard came out, and it's called IPv6. We have a couple trillion possible combinations. Yeah. DNS stands for Domain Name Service, and that's the telephone book of the internet. I'm sure many of you never even seen a telephone book. But back when I was growing up, we'd have this white book and a yellow book where we'd open it up and find people's addresses and phone numbers. Now we use the internet for it. But we now, through this DNS, register a domain name like MSMC, along with the .edu to distinguish the Mount from, say, the Mount St. Mary's University in Maryland. So that domain name is what distinguishes us. So let me get out of this view. Actually, I'm going to stay here for a second. I'm going to run another computer called Traceroute. What this is, it's seeing how many steps it takes me to get to the Mount's website. These steps are different routers with different companies, wherever they may be geographically located. So we see I'm going to 1, 2, 3, 4, 5, 6, 7, 8. I'm on my 9th stop, and I finish with number 11. So this is the internet protocol address of the web server hosting msmc.edu. And this is all the routers it took to get there. And that's what the internet is. It's putting packets of data from our keyboard and mouse, sending it out through a web browser, connecting to web servers that connect to app servers and database servers to finally get that msmc.edu that we direly needed. We now dive into ways to communicate. You all will be much more familiar with social networking than me. I'm the generation that is Facebook, Twitter, which is now, we know, to be X and LinkedIn. So most people share pictures, video, other means to be socially connected to someone else. In Twitter, we have short bursts of information. LinkedIn, again, with a professional social networking platform. You could bring up any other ways you all know to communicate, Instagram, and so on. All enabled by the internet itself, all based off of a model way back in the day from AOL called AOL Instant Messenger. IM was the first means to communicate directly that wasn't email related. Now, email, we know, is a primary source of communicating. You use a service of some kind. We use Gmail at the Mount. We also use Microsoft 365 at the Mount. You may have an account with Gmail itself, or maybe Yahoo or another free service. It is my hope that each of you keep your profiles to social networking private. If your person is actually a influencer, you'll want to have at least two accounts, one of which is private, one that you keep to your family and friends, and the other you can make public for anyone to contact you, DM you, buy off of you. None of these sites were really meant to monetize oneself, but with the explosion of YouTube, we found ways to generate income outside of traditional lines of business. And now companies actually seek out influencers with millions of followers. So again, if you're just working with yourselves, keep those private. Other communication tools we use are Google's whole platform of business communication, Google Docs, Google Drive, Google this, Google that. We have Microsoft 365. And Teams is part of Microsoft 365. Hangouts part of Google Suite. And we have Zoom, which we're using now. We see Instagram, YouTube, Flickr, and SoundCloud are ways we could share pictures, video, music. I get my music from Apple Music, but wherever you get it from, I hope you're enjoying it. Other ways we communicate are through video logs or vlogs. Not many people blog with text these days. I'm not going to make you create your own blog, but it's just a means to get thoughts that you want to share with someone, usually with some kind of paywall behind it, so the content provider can get paid. Podcasts are really blowing up, as are webcasts. Look at In the Heights a couple weeks ago when they had Taylor Swift on. This is the Kelsey brothers. It broke the bank for hits on a webcast. Just a means to, again, get something out there you want to share and more likely than not get monetized over. Emails, like I said, primary communication, written, asynchronous. It's very convenient. It's, I won't say not private, but you have a sense of privacy. And with business email, it is never private. Your employer owns that email. We all know that web-based email platforms. I'm not going to talk about a desktop client because frankly, that's a technology that's been displaced, but I will talk about etiquette. And I will talk about do's and don'ts of internet. So the first thing we do when we get an email should be to check the sender. We hover over their name and we see the email address. And if it's familiar to us, we move on. If it's not, something known to us, we either delete it or we send it to some fish alert service. Next, we go down to the body of the email. If we think the email address from the sender was good, we look at the content. And the first thing we look at is urgency of the email. If you get an email saying, hey, log into your bank right now, pass us your credentials to see some new offer or something like that, more than likely not, that's what's called a phishing scam. They're looking for you to trust your email to be private and secure, to be able to send you things to click on to enable them to take over your computer, like what currently is happening now at Marist. We hover over links and files. Unless we know and expect a file to come, we never download it. What you can do is you get a file in your email, you call the person that sent it and verify they sent it, verify that it was clean on their end. We don't want to say anything inflammatory in our emails. We don't want to question anyone's judgment. We can offer up our own opinions, but don't raise questions of someone else's opinions. We don't write in all capitals. We don't write in all bold lettering. We do have some kind of service that checks our spelling and grammar, like what I use, Grammarly. We talked about texting and instant messaging already. Cloud, internet computing. If we looked what's inside our computers last week, we got a kind of a handle on what a server computer is. Server is a, well, let's do this. Give me 1 second. What we're looking at here is an IBM Z series server. It is in a full-size equipment rack and it has many what's called blade servers, which are something like this. So these all get put in a cage like we just seen and are the backbone to cloud computing. What happens, we take all these physical servers, we use its resources to be able to sell those resources back to someone on a consumption basis virtually. Meaning all the servers we're going to be selling on here are not real. There's just a software program that makes them look like they are real. That's my little show and tell. Blade server. So let me stop this share and head back to our slides. So like I said, we have a consumption model here. So we're asking a company to store data for us. We may ask them for a server for ourselves to communicate some way, like to build a web server or a database server. So we'll subscribe to memory, CPUs, network cards, storage, whether we're going to manage the operating system on those servers or not. The big advantage of cloud computing, though, is we're taking data centers that are local, we're moving them to the internet, where more people have access to them 24/7. If we look at Google Drive or Microsoft OneDrive, Dropbox, or iCloud, those are all cloud-based storage providers where we can securely store data. Applications we get off, say, in App Store are stored in the cloud and ready for us to download and use. But think of it as normal everyday computing, but virtual on the internet. Our author then takes us into the world of e-commerce, where you have business to consumer. Think of, I'm a big Fanatics.com fan. They're a big B2C vendor. Look at business to business. Look at who provides food services at the Mount. That's all ordered through an extranet, where extranet is an external piece of the internet where one company allows access to their network to another. So our food service provider is able to take orders from Mount culinary teams through a secure connection. And consumer to consumer, I already gave references to like eBay, Mercari, Poshmark, and like Etsy. We talked about monetizing ourselves socially already. The biggest use of e-business, e-commerce today is mobile commerce. We see someone connecting with Apple Pay, Google Pay, Samsung Pay, anyone you mother pay. The chips on our cards, our bank cards or credit cards that we store in the wallet of our cell phones for those services. That's all mobile commerce. Ordering off of our smarter devices, any kind of B2C, B2B. C2C is mobile commerce, the big and growing sector of e-business today. How do we make our shopping experience safer? First thing we do, we never shop at a site that doesn't have HTTPS or a lock icon in our web browser. So let me do this. Stop share for a second. I'm going to go here, close out of here. So I hopped on Fanatics. Notice in my browser where my cursor is a lock. If we click on it, we can see my connection is secure. We have a certificate, a piece of digital paper that shows we're distinctly us. The second thing, some browsers may not show the lock, but they'll be distinguished in our URL, our Universal Resource Locator, that's built on this DNS premise I've told you about before, HTTPS. If we're not at either one of those, we're not going on here, going to our class favorite team, the Bills, and we look to buy this Crucial Catch for Cancer hat. So this is a very big example of business to consumer selling. It also shows us URLs, DNS, and that client server computing we talked about. Because I typed in a browser, fanatics.com, my browser, which I'm using Microsoft Edge right now. Edge is the installed browser on all Microsoft computers. For Apple, the embedded browser is Safari. For Chromebooks, it's Chrome. We can install other browsers on these devices. I'm a big fan of Google Chrome myself. Some people like DuckDuckGo or Firefox. This is just what I prefer. So we've seen a lot of things by just looking a little bit at how web browsers work. So let me stop my share again. We'll go back into our slides. When we want to shop, we don't use public computers. So you wouldn't want to go to the library and connect to one of the computers there and buy. You wouldn't want to buy when we're at a non-secure Wi-Fi. Like you want to go to Starbucks and do your banking or do your buying. You don't want to do that from a free Wi-Fi source. You can do, however, is if you're on your computer, you can use your phone's hotspot, which is totally secure to do any banking or shopping. But I would suggest against even that because there could be people around looking at your computing and may be able to find out things about yourself. Use well-known reputable sites. Don't just jump on every cheapjersey.com website when we want a cheap, say, NFL jersey. Use ones that are known that have ratings. We use a credit card, not a debit card. Debit card, for one, I don't use credit cards myself, so I'm against this rule. But sites can put holds on your debit card for more than the amount you purchased, and will then release it at some other time. You want to see a site's return policy. You want to see if they have currency conversion and language conversion. We talked about browsers. We talked about our URL bar, our address bar, tabs. We can have multiple tabs in our browsers. Be warned, however, each one of these tabs is another full browser running on your computer and using up your resources. So if you have 30 tabs open, the browser is going to be kind of slow. This picture is showing a Chrome window with incognito. Each one of the browsers we just talked about will have a private browser where we're not sharing cookies. Cookie is not something we can get down in the cafeteria. My favorite would have been peanut butter. It's a small digital file that has your computer's name, your IP address, the domain you're computing from, and that cookie enables the web server to be able to know who you are. Be warned, if we accept cookies from a site, they have the ability to then market to us. It's a product of a paradigm called opt-in versus opt-out. When you give your email address and set up an account, you're opting into communication from that web page, website. If you opt out, you'll more than likely be able to browse the site, but you may not get very good use out of that site because it is requiring you to do something more. I talked about URL a lot, and it starts with HTTP, which we see here, and that stands for Hypertext Transfer Protocol. It's what the internet is built on. Our domain name is www stands for World Wide Web. Our domain name or first level domain is called, in this case, New York Times, MSNBC. Our top level domain is called .com, .org, .us, whatever you want. And then we can have further subdirectories all the way down to a host name. Some typical top level domains are shown by our authors. A hyperlink is just a copy of the URL that you can use for some other purpose. Bookmarks are where we save a page for future browsing. History is where we've been in any given section. And tagging is the way we let us know what's what. Things that can affect our browsing is a large history, and you can clear that web browsing history. So our author then goes into search engines and how we get better results. And we look for what authority is giving us our resource. If there's any bias prevalent in the documentation, its relevance to the query you put in, the audience it's trying to reach, and other citations or references it may have. So I'm going to stop my share again for a second. This is the page to our Kaplan Family Library. I wouldn't be doing my job if I didn't tell you to start your research for any project you're given here. So you just go to find information and you find the platform you may want to see something about. So right now I'm going to look for an article. I'm going to say all databases. And I'm going to narrow my search down to computer science and technology and my IEEE journals. Hopefully I'll get there. So here's the IEEE Explorer. So let's look up, we want to write a paper on cloud computing. Now, all of these will have some kind of relevance built in. We can narrow down a range of our research. We want to get things that are as close to now as possible. So here's some recent references on the use of cloud computing. You can find any topic you may want to ever see in our library. We can look at whatever digital news that the Mount subscribes to. That's the New York Times and Wall Street Journal. We can look at streaming video. We could see things that our faculty have written. There's a help feature, in particular citation tools. There's some formatting guidelines here. And we can see the services for you all our students. So I want you to start all your project work right here. Let me stop share again. AI has brought us a world of fakes, deep fakes in particular. You can look on and search anything in Instagram, and you can, more likely than not, most of the results will be deep fakes. Now, these images and sounds are easy to predict and look at. If you don't see any activity in a background of, say, a particular picture or reel, we know a deep fake's running it. If you don't see blinking patterns like you and I typically have, you have a deep fake. If you see body proportions that aren't the normal person, we more than likely have a deep fake. There's avatar programs that could like replace me on this Zoom video. There's applications that can do that. It does make, life a little easier. You don't have to look at my mug all day. You can look at some avatar that's going to be much prettier to me that can use my same voice, my same mannerisms. So let's be alert of where and when we may have deepfakes. I don't know why my line is drawn again, but we'll have that not do that. Any place where we can post something into a website, a web page, an app, we want to put up timely information that's been vetted by more than a couple sources. And if we don't know something's truthful, we don't pass it on. And we don't cite riots with people in platforms like X. We don't cyberbully. We don't use cyber terrorism methods, and so on. Why can't I post whatever I want? Because you never know how someone's going to react to it and then in turn do something back to you. How can I be responsible for something I didn't know was wrong? Don't post it. How can I behave in a way that shows that I'm a mature professional? We use complete sentences, proper punctuation. We don't use all capitals. We don't use bolds. We put out good information. We have profiles set up on sites with our picture. I believe that it's okay to be private on the internet, and I encourage it. It's not okay to be anonymous, meaning you're trolling around sites and not putting out who you are. And that's it for this week, everyone. Thank you, and we'll talk to you next time around.